In this video, we'll look at an epsilon-delta proof. We want to prove that the limit as x approaches -4 of this function is equal to -10. Now we can verify that this is just a simple linear function. We can verify that by looking at it. But let's talk about how we would actually prove that using epsilon and delta. Basically, we want to find delta so that when the distance between x and -4 is less than delta, then the distance between our function 3x plus 2 and the limit, in this case -10, is less than epsilon. So epsilon is given, it's any epsilon. Our goal is then to find delta. Since we don't know what delta is, that's our first goal. We're going to assume this piece is true. So we're going to start with this information. We'll start here. So the absolute value of 3x plus 2, and then the minus -10 is really plus 10, is less than epsilon. So we're going to clean this up and simplify this expression on the left, and our goal is to make it look like what we have here, which is essentially absolute value of x plus 4 is less than delta. We really want the inside of the absolute value bars to be x plus 4. Let's see if we can make that happen. So we have the absolute value of 3x plus, we'll add 2 and 10 to get 12. And that is still less than epsilon. We can factor out a 3 inside the absolute value. We'll have absolute value of 3 times x plus 4. And that is, again, less than epsilon. So we're getting close. Again, we want x plus 4 inside the absolute value. Notice that 3 is a positive number and it's inside the absolute value bars. Since it's already positive, we can simply pull it out of the absolute value. And we have 3 times the absolute value of x plus 4 is less than epsilon. And now, again, our goal is to get x plus 4, so we can simply divide by 3. We'll get x plus 4 is less than epsilon divided by 3. What we now have is essentially an equivalent statement to what we started with. It looks a little different, but they are equivalent. We went through algebraic steps to get here, so it's an equivalent statement. We'll use this now to be the delta that we're looking for. We're going to choose a delta value that is epsilon divided by 3. Now we will assume that the absolute value of x plus 4 is less than delta, which we are now rewriting as epsilon over 3. We're going to assume that this expression is true. Now our goal is to state that this statement is less than epsilon. So let's go back to what we had there. We have the absolute value of 3x plus 2 minus -10. And again, our goal is to prove this piece. We want this to be less than epsilon. The next few steps are going to look familiar because we did most of them already. We'll have 3x, 2 minus -10 is plus 10, so that will give us plus 12. We can again factor out a 3. and again pull the 3 outside of the bars. At this point, it gets a little different from what we did earlier. We know that the quantity absolute value of x plus 4 is less than epsilon. So we can say that this expression is less than 3 times epsilon over 3, which we know to be epsilon. So we started with assuming the delta statement, absolute value of x plus 4 is less than delta, which we rewrote as epsilon over 3. And then we concluded that the absolute value of 3x plus 2 minus negative 10 is less than epsilon. That's what we wanted to prove. And that's essentially the end of the proof. So we can say QED, we've finished. We've proven what we wanted to prove. Here we have another example. This time we want to prove the limit as x approaches 4 of the function is equal to 1. Again, this is a relatively simple linear function, so you can graph that and verify it if you want. But we want to use epsilon-delta statements to actually prove that it's true. So we want first to find a delta so that when the distance between x and 4 is less than delta, then the distance between the function negative 1/2 x plus 3 and our limit 1 is less than epsilon. So again, we're going to start with this piece here. So off to the side, we need to find delta first by looking at this piece. We'll go through the steps and clean this up a little bit. We have negative 1/2 x plus 2 less than epsilon. And remember, our goal here is to make the stuff inside the absolute value bars look something like this, x minus 4. So to do that, we're going to factor out a negative 1/2. So we'll get x minus 4, close the abs value, and less than epsilon. Notice that we have negative 1/2 here, but it's inside the absolute value. So we can make that a positive 1/2. Since it's inside the absolute value, it's going to be positive. So we can force it to be positive. And similar to what we did last time, we can pull that positive 1/2 outside of the absolute value. And from here, we can multiply by 2 on both sides. That's going to give us that the absolute value of x minus 4 is less than 2 times epsilon. Now remember, that's what we want to use to help us with delta. So again, we're going to suppose that epsilon is given, epsilon greater than 0 is given, and we're going to choose delta this time is 2 times epsilon. And our goal now is to prove this piece. So we have absolute value 1/2 x plus 3 minus 1. And let's simplify what we have. negative 1/2 x plus 2. Again, these steps look very similar to the ones from earlier. We'll factor out negative 1/2. Make that 1/2 positive. Since it's inside the absolute value, we're allowed to do that. We'll pull the positive 1/2 out of the absolute value. So what we have now is 1/2. We can replace the absolute value of x minus 4 with the 2 epsilon. And this is now less than our previous statement, which is now epsilon. Thus, since we have epsilon, we started with this statement and we found that it is less than epsilon, which is what we wanted up here. We've got it. The absolute value of negative 1/2 x plus 3 minus 1 is less than epsilon. And we've got our proof.